Hello good day viewers. In this tutorial we are going to differentiate this implicit function in two different ways, and I want you to choose the best method. Let's get started. Alright, in our first method I would like to apply product rule. Why? Because we have product x squared times y cubed. We have two functions multiplying each other. Likewise here we have another multiplication, and hence we are going to apply product rule. Remember that if you have y to be equal to u multiplied by v, for which both u and v are functions of x, dy over dx is equal to u multiplied by dv over dx, then plus v du over dx. What does this mean? It means you should keep the first one constant. You see we have u here, we have u here, it is constant. Then we differentiate v with respect to x. Then we add, this time around we keep the second one constant, we differentiate the first one. And that's exactly what we are going to apply in differentiating this function from left to right. Alright, let's get started. So from here, I would like to keep x squared constant, then we multiply by the derivative of y to the third power. If you differentiate y to the power of 3 applying power rule, the power will drop down to multiply y, and you have to reduce the exponent by 1. 3 minus 1 is 2. But remember that y is a dependent variable. Then you multiply by what? Dy over dx. Then you move ahead, you add. This time around we keep y to the third power constant. Then we differentiate x squared. If you differentiate x squared, you have 2x. Because the power will drop down to multiply, and you reduce the exponent by 1. 2 minus 1 is 1, which you don't have to write. Remember, y cubed is constant here. Then you move to the next one, plus. I would like to keep this one constant. That is y squared. Then multiply by the derivative of x cubed. 3 will drop down to multiply x. Then you reduce the power by 1. 3 minus 1 is 2. Then you add. This time around, I will keep x to the third power constant. Then we differentiate this one. 2 will drop down to multiply. Then you reduce exponent by 1. That is 2 minus 1 is 1. Then remember we are differentiating y multiplied by dy over dx. And this is equal to the derivative of 0 is still 0. Alright, let me simplify and collect the like terms. Here we have what? 3x squared y squared, 3x squared y squared, dy over dx, plus 2xy cubed, plus, if we multiply this, we have 3x squared y squared, 3x squared y squared, then plus again 2x cubed y, 2x cubed y, dy over dx. This is equal to 0. Let us bring those with dy together. We have 3x squared y squared dy over dx. Then we have another one here which is plus 2x cubed y dy over dx. Then any other term that does not contain dy over dx, we are going to take it to the other side. If you take this one to the other side, it becomes negative 2x y cubed. If you take this one to the other side, it becomes negative as well, 3x squared y squared. Then you factor out dy over dx from these two terms. We have dy over dx outside. Inside we have this left, that is 3x squared y squared, then plus this one, that is 2x cubed y, and this is equal to negative 2x y cubed minus 3x squared y squared. Alright, next we are going to divide both sides by this, leaving only dy over dx to the left. Dy over dx is equal to negative 2xy cubed minus 3x squared y squared divided by 3x squared y squared plus 2x cubed y, and we are done. This is the first method. Now let me show you the second method. All right, the second method, I would like to use formula dy over dx is equal to negative minus f subscript x divided by f subscript y. What does this mean? It means we should differentiate the function, the entire function, everything, with respect to x alone. Therefore, y will remain constant. Then we multiply everything by negative sign or negative 1. Then you divide by f subscript y, meaning you should differentiate the entire function with respect to y alone, treating x as constant. What do we mean by constant? Remember, if you have 2x to the third power, if you differentiate this, 2 here is constant. So the 3 will drop down to multiply 2. We have 6x. Then you reduce the power by 1, it becomes 2. The same thing, if you have, for example, x, y cubed, and you wish to differentiate with respect to y, this will be constant, and this 3 will drop down to multiply x. So you have 3x, then y squared. This is what we mean by constant. So let's get started. From left to right, we want to differentiate x only, treating y as constant. Therefore, dy over dx is equal to negative the whole of the derivative with respect to x. This will remain constant. You're only going to differentiate this. If you differentiate x squared, you have 2x multiplied by y cubed. So we have 2xy cubed. You're done with this one. Then you move to the next one. Differentiate x alone. This will be 3x squared. If you differentiate x cubed, it will be 3x squared. But we have our constant y squared. That is 3x squared y squared. 3x squared y squared. Then you divide by, this time around we are going to differentiate with respect to y alone. So we are going to differentiate this. Y cubed will be 3y squared x squared. That is 3x squared y squared, right? 3x squared y squared. Then you move to the next one, differentiate this again. It becomes what? 2y. Then you multiply by x cubed. That is x cubed, 2x cubed y plus 2x cubed y. I just like to write x before y, but it doesn't matter. Multiplication is commutative. All we have to do is to distribute this negative sign. You can see that this would be negative 2x y cubed negative 3x squared y squared divided by 3x squared y squared plus 2x cubed y. This is nothing but dy over dx. So just to relate, you see, in just 2 steps, we are able to solve this problem. I can even solve it in the first step because I can distribute this negative directly if I so wish. But just look at the answer, the final answer. Are they not exactly the same with this one? They are. If you like, you can copy this one, bring it together to relate. They are exactly the same. Let me draw it here for you to see. Is there any difference? No difference at all. So it's left for you to decide which approach is better for you. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.